One property of acids and bases is called its strength. So we classify acids and bases as two different types. There's strong acids and bases and weak acids and bases. So let's look at the difference between these two things. So first, if we look at strong, so here's the word strong. So what strong has to do with is how much the acid dissociates. Now remember, what dissociates means is that it separates or falls apart into its ions. So a strong acid or a strong base will have 100% of the acid or the base dissociate in water. This is the type of reaction which would get a straightforward arrow. So for example, we did this one right here already, HCl. So it would be like HCl was in water and 100%. So they use an arrow that just looks like that, goes to make the ions, 100%. Okay, so we get a straightforward arrow. Now, in general, if you had to know strong and weak acids, what you do is you would memorize the strong acids and the strong bases. This is a limited list, and then you would know if the acid or base is not on the strong acid and base list, then it must be weak. For our class, I'll give you the strong acids and bases. You do not need to memorize what they are. What you do need to know is that word strong means they're going to 100% go to their products. So 100% to make the ions. Now, you might be able to then reason that if you had a weak acid and base, so down here, weak acids and base, what that means is not a lot of the acid or base dissociates into the ions. So if you see here, only a small fraction of them will make the ions. Now this is an example where we would get a back and forth arrow. So for example, I'll take HF. So HF, if I put it into water, then only some of it would make the products because only a small amount dissociate. So we would get products still, but only a small amount of the products. And so they use the back and forth arrows instead of a straightforward arrow, telling us that there's only a small amount of ions and a lot of it remains as products. So we're going to look at some of the consequences of this, and we'll do on another video, I'll show you how you can use some of this information. But from this slide, what I want you to know is that there are categories of acids and bases, strong and weak. Strong means that they 100% dissociate to form the products. So everybody goes to the product side. Weak acids and bases, a little bit of the chemical goes to the product side, and quite a bit of it still remains on the reactant side. Now we'll see, I have a table here in just a little bit. It's not the next slide, but the next one. So in 2 slides that will show you that all weak acids are not the same. So all strong acids are the same. They're all 100%. You see right here, 100%. Okay, so there's no variation. But in weak acids, it just says only a small fraction. Well, weak acids can vary in what that fraction is. And we don't have to know any numbers. We just know that some weak acids are stronger or make more products than other weak acids. So another relationship when we're talking about weak acids is their partners. So remember, we talked about that when an acid donates its proton, an H+, it becomes a conjugate base. So we have acids and conjugate bases. They're partners. So a strong acid, and HCl is an example, has a weak conjugate base. It's an inverse relationship, right? So the stronger the acid, the weaker the conjugate base. So the partner is always the opposite of where it started. So if you look down, a strong base would have a weak conjugate acid. Now, likewise, which I don't have an example here, but if I had a weak acid, it would have a strong conjugate base. So see, they're opposite. Well, I don't even think about it as opposite. I kind of think of it as complementary. And if we had a weak base, it would have a stronger conjugate acid. So the stronger the acid, the weaker the conjugate base is, and the same with the base. So it's like an inverse relationship. So as one gets stronger, the other one gets weaker. So here's the chart I mentioned previously. You will be given this table because we're going to use it to do something in the next video. But I kind of like it. So it has some acids and their conjugate bases. So you can read so there's the acids. Oh, let me get a lighter highlighter. Let's see. That might be the lightest one I have. I'll try a different color and see. Oh, no, that makes it disappear. Sorry. I might not. So here's the acid and here's the conjugate base. Okay, so they're partners on this side. And if you notice, on the left-hand side, it says increasing strength. So that means we have the strongest of the acids up here and the weakest of the acids down here. Now remember, their conjugate bases are an inverse relationship. So here it says increasing and it's pointing down. So here we have the strongest of the conjugate bases, and up here we have the weakest of the conjugate bases, which is what we were just talking about. Stronger acids have weaker conjugate bases. So now I have a question, and I will have to go back and forth between the slides because we're going to need this table to answer our question. So this says, using table 9.2, which you'll be given, label the stronger acid in each pair. Then it says, which acid has a stronger conjugate base? Okay, so first let's find a stronger acid. So letter A, this is sulfuric acid, H2SO4, and phosphoric acid, H3PO4. Let's look. So H2SO4 is here, and H3PO4 is here. So as far as the acids goes, the higher you are on the chart, the stronger you are. So H2SO4 is the stronger. So H2SO4 is the stronger acid. And I got that from the table. Now, and then it says which acid has the stronger conjugate base. So for me, I have to think about this, and I think, okay, what we learned is weaker acids, it's an opposite relationship. So weaker acids have stronger conjugate bases. Remember, they're opposite. So that means that the one with the stronger conjugate base must be the weaker acid. And so in this example, H3PO4, which is the weaker acid of the two here, has the stronger conjugate base. I'm just going to put CB here for conjugate base because I'm running out of space. All right, so what I would do now is why don't you pause and you try to answer B, C, and D. And then once you get it down, unpause, and I'm going to continue on and I'll give you the answers. Okay, so letter B, I have to look for HF and HCl. So let me erase what I have up here so it's easier to see. HF and HCl. So HCl is higher, so it is the stronger of those two. So HCl is stronger because it's higher on the table. And that means HF is the weaker acid, so it has the stronger conjugate base. Okay. H2CO3 and NH4. Okay, let me again erase this so I can see. H2CO3 is right here. Oh, and NH4 plus is right below it. So H2CO3 is stronger because it gets stronger as you go up. So H2CO3 is the stronger acid. And the one with the the stronger conjugate base is the weaker of the two. So NH4 plus has, of the two, we're just comparing the two, the stronger conjugate base. Okay, and letter D, HCN and HF. So HCN and HF. So HF is higher on the table. So that means HF of these two is the stronger acid. And HCN has the weaker conjugate base. All right, so that's a little bit about being strong and weak. In the next video, I'm going to show you one example of where you can use the strength to figure something out.